In this video, we will prove binomial theorem. So first we have to know about these identities, which I have written down here. The first one is NCR is the same as NCR minus N minus R. And the second one is NCR is the same as N minus 1 CR minus 1 plus N minus 1 CR. And the last one is NC0 is the same as KC0 for any NK. So we will use these identities in order to prove the binomial theorem. So the binomial theorem states that for any positive integer n, we have x plus y to the n is equal to nc0 x to the n, nc1 x to the n minus 1 y, nc2 x to the n minus 2 y square dot nc n minus 1 x to the 1 y to the n minus 1 plus ncn y to the n. It can be written in the summation notation as well. I can write ncr x to the n minus r y to the r, because you can see in every term here you have n plus 1 terms. You can see in each term here n is fixed in each term, and for every term here you have r. But notice for every such r, you can see this r has been subtracted from n and it is the power of y. So I have done the same thing. This r is subtracted from n and it is the power of y. You can see this thing for every such term. You can see here in all of these terms we have the same expression. So we have put an index which is r, and we have used the summation notation to simplify our expression. Now look at the proof. We will prove this theorem by using mathematical induction on n. So we have 3 steps to prove it. The first one is the basis step. So in the basis step, we have to prove that the statement is true for n is equal to 1. So in order to prove the statement for n is equal to 1, we have to check left hand side for n is equal to 1 as well as right hand side for n is equal to 1. We will check whether we are getting the same answer or not. So let's do for n is equal to 1 left hand side. So left hand side will become x plus y to the 1, which is the same as x plus y. Now we will put n is equal to 1 for the right hand side. Here you can see. So we have put n is equal to 1 in the right hand side. You can see here. So this is the summation from 0 to 1. So we have to put r is equal to 0 and then we have to put r is equal to 1. So first look, 1c0, when we put r is equal to 0, x to the 1 minus 0, y to the 0. Now put r is equal to 1, we will get 1c1, x to the 1 minus 1, y to the 1. So you will get 1c0 is always 1. We will get 1. 1 times x to the 1 minus 0 is 1. Y to the 0 is 1. Next, 1c1 is always 1. We will not write 1. X to the 1 minus 1 is x to the 0. X to the 0 is 1. We will not write 1. And this is y to the 1. So you will get x plus y, which is the same as left hand side. You can see here. So left hand side is equal to right hand side for n is equal to 1. So first step has been shown. Now we will move towards second step of mathematical induction. This step is called induction hypothesis. In this step, we will assume that our statement is true for n is equal to k. So we will assume that this statement is true for n is equal to k. So we will write the same statement here, but we will replace n by k. So we have assumed that the statement is true for n is equal to k. So we have replaced n by k in the given statement. Now we will move towards our last step, which is the main theme of the proof. This step is known as inductive step. So in the inductive step, we will prove that the statement is true for n is equal to k plus 1. So we will take left hand side for n is equal to k plus 1, and we will get right hand side for n is equal to k plus 1 by using previous results. So for n is equal to k plus 1, left hand side is x plus y to the k plus 1. We can write this term in this way. We have assumed that x plus y to the k is the same as this expression. So here we have x to the y, x plus y to the k. So we will put this value of x plus y to the k here. So we have put it down here. Now we have two values, x and y. Now first multiply this value with x, then multiply this value with y. When we multiply this value with x, we will get the power of this term will be increased by 1 because we are going to multiply by x. So we will get summation r from 0 to k as it is, kcr as it is, x to the k minus r plus 1, y to the r. We have multiplied this factor by x. Now multiply this factor by y. When we multiply this factor by y, these terms will remain unchanged, but y to the r will be changed because we are going to multiply by with y. So we will get y to the r plus 1. So we will get summation r from 0 to k, kcr, x to the k minus r, y to the r plus 1. Now we have two summation expressions. We will expand them one by one because in each summation expression we have k terms. So we will put r is equal to 0, r is equal to 1, r is equal to 2 up to r is equal to k. We will get k terms here, then we will get k terms here. So first put r is equal to 0 in this expression. You will get kc0 x to the k, r is equal to 0, so k plus 1. Here also r is equal to 0, we will get y to the 0. Now put r is equal to 1, you will get again this expression kc1 x to the k minus 1 plus 1. We are putting r is equal to 1. Now y to the 1. Now put r is equal to 2, you will get kc2 x to the k minus, now you are putting 2 instead of 1, so k minus 2 plus 1. Again here you have to put 2, y to the 2. So we will do this work, we will carry on this work up to k minus 1 and then k. Now put r is equal to k minus 1, you will get kc k minus 1 x to the k minus 1 plus 1, y to the k minus 1, and now put r is equal to k, you will get kck x to the k minus k plus 1 y to the k. Now we will do the same thing for the second expression as well. So we will write plus. Now put r is equal to 0, 1, 2, 3 up to k minus 1 up to k in these terms. You will get this term first, then you will get nc1 x to the k minus 1 y to the 1 plus 1. Now put r is equal to 2 nc2 x to the k minus 2 y to the 2 plus 1 up to dot 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 plus. Now put r is equal to k minus 1 here in this expression. So you will get kc k minus 1 x to the k minus 1 y to the k minus 1 plus 1. Now put r is equal to k. You will get kck here, kck x to the k minus k y to the k plus 1. So these are the total terms. This is the same as, you can write this term k plus 1c0 x to the k plus 1. Why I'm writing k plus 1 instead of k? Because I have to prove it for n is equal to k plus 1. And why they are same? Because I have already told you about some identities in the start. You can see here, when this term is 0, then whatever you put here, you will get the same answer. Because here you have 0, so there is no difference. What we put on the above, we will get no change. Now write down the second term, plus kc1 x to the k y to the 1 kc2 x to the, what is this? This is k minus 1 y to the 2 plus dot dot dot. Look at this term. This is kc k minus 1. And what about this power? This is k minus k, which is 0, 1 plus 1 2, x to the 2 and y to the k minus 1. So what about this term? This is kck x to the 1 y to the k. Now look at this term. This is kc0 x to the k y to the 1. Okay, now look at this term. This is kc1 x to the k minus 1 y to the 2 plus, look at this term. This is kc2 x to the k minus 2 y to the power 3 dot dot dot. What is this? This is kc k minus 1 x to the this power. This is k minus k, which is 0 plus 1. So x to the power plus 1. And what is this? Y to the k. Look at this term. This is kck x to the k minus k, which is x to the 0. X to the 0 is 1. We will not write. We will only write y to the k plus 1. Right? So now we have written down all these terms. You can change this last expression by replacing k plus 1 here as well, as you have did in the first expression. We have replaced n k by k plus 1. We will get no change here as well. So I have written down k plus 1 c k plus 1 y to the k plus 1. So what will I do to the remaining terms? Okay, so we will not change first and the last terms. We need these terms as it is. So we will solve remaining terms. So first term has been written down as it is. Now look at this term. This is x to the k times y. Find the term which is similar to this term. You can see that is here, x to the k times y. We will add their coefficients and these terms will be taken as common. So we have written down this thing. Their coefficients have been added and x to the k times y have been taken common. In the next, look at this term. This is x to the k minus 1 times y square. Where do you have such kind of term? You can see this is the same as this. You can see. So their coefficients will also be added. Their coefficients are kc2 and kc1. So we have added their coefficients and we have written down x to the k minus 1 times y square. We will move further. Look at the last term here. You can skip this term because we are not interested in this term because we have written down dot dot dot. So I'm going to write the last term here. The last term is xy to the k. Where is xy to the k? This is here. You can see xy to the k. So in these two terms, the coefficients that are kck and here kck minus 1. So we will add them. And what about the last term? We will write down it as it is. Now we have to add these coefficients. You know, we have given the formula to add these coefficients in the start of the video. You can see. So here it is. NCR is equal to n minus 1 CR minus 1 plus n minus 1 CR. So we have this formula, but now we don't have n minus 1 because here is k, here is k. So we need this formula in n. So we replace n plus 1. If we write n plus 1 CR, we will get, here you will write n plus 1 instead of n, you will get n. And what you will get here? You will get here r minus 1 and here n and here you will get r. So we have only replaced n by n plus 1. R will come as it is. So we will use this formula instead of this. So now first term will come as it is and apply the formula on this term. In this term, k is replaced by n is replaced by k, and here r minus 1 and r. So here r is 1, so r is replaced by 1, n is replaced by k, and r is replaced by 1, because if I replace r by 1 you will get kc0 and then you will get kc1, which is here kc0 and kc1. So r is replaced by 1 and n is replaced by k. So here you will get n is equal to k and r is 1. K plus 1 over c1, and you will write this thing x to the ky. Now apply the same formula for this. So compare this with the formula n, and here you have k, so we will replace n by k. Here you have r minus 1 and r, and here you have 2 and 1. So here r is 2, right? R minus 1 is 1. R is 2 and n is k. So put n is equal to k and r is 2. We will get k plus 1 c2. And what is this? X to the k minus 1 times y minus 1 times y square. Next we will write, so what is this term? Again compare it with this term. You can see above we have k, here above we have n, so n will be replaced by k, and here you have k and k minus 1, so r is equal to k and r minus 1 is k minus 1. So we will replace r by k. N will be replaced by k and r will be replaced by k. You will get k plus 1 c k, and then this term is xy to the k. And what is the last term? This is k plus 1 ck plus 1 y to the k plus 1. So this is the right hand side for n is equal to k plus 1. So we have proved binomial theorem.